Hello and welcome back. The following problem states combustion of a 5.50 gram sample of benzene produces 18.59 grams of CO2 and 3.81 grams of water. Determine the empirical formula and the molecular formula of benzene given that its molar mass is approximately 78 grams per mole. So very first thing, when we're doing a combustion analysis, we know we have some organic molecule, CX, HY, OZ, plus oxygen, which gives me CO2 and water. We can go ahead and use the masses of CO2 and water to determine how much carbon, the mass of carbon is, and the mass of hydrogen. Once we find the mass of carbon and hydrogen, we can determine, based off of the how much of sample we started with, if there's any oxygen in our system. Then we can find the empirical formula based on the number of moles of each, and then we can determine the molecular formula because they gave us the approximate molar mass of it. This is a multi-step problem, and there's going to be a lot of things that we're going to be doing, so it's very important as we go throughout, you understand why we're doing each of the steps. So in step 1, we're going to determine the mass of carbon and hydrogen in order to determine if we have any oxygen available and to then go into the how many moles is present as well. So for step 1, let's go ahead and start off with carbon. They give us an 18.59 gram sample of carbon, and we need to go to grams, of CO2. We need to go to mass of carbon. Well, in order to do this, we need to go from grams to moles of CO2, and we can use the molecular weight for CO2. And then once we have moles of CO2, we can use the relationship that for every 1 mole of CO2, we have 1 mole of carbon. So it's a 1-to-1 ratio to get moles of carbon. But we want to eventually convert it to grams of carbon, and so we're going to use the molecular weight again to go to grams of carbon. So let's go ahead and follow this think map. So the very first thing that we need to do is go to moles. We're going to use the molecular weight of CO2, which is 44 grams. So we do the reciprocal, so 1 mole of CO2 per 44 grams of CO2. Grams and grams cancel out. And now I have moles of CO2. But I don't want moles of CO2. I want moles of carbon. And we know for every 1 mole of CO2, we have 1 mole of carbon. So moles and moles of CO2 cancels out. And then we can go to grams of carbon by using the molecular weight of carbon, which is 12.01 grams of carbon per 1 mole of carbon. Mole and mole cancels out, and I end up with a mass of 5.073 grams of carbon. I'm going to follow the same exact think map, but instead of carbon, I'm going to do it for water. However, in the case of water, it's a 1-to-2 relationship. For every 1 mole of water, we have 2 moles of hydrogen. So this is for carbon. Let's go ahead and do this for hydrogen. So we start off with a sample of 3.81 grams of water, multiplied by the molecular weight of water. 1 mole of water is roughly 18 grams of water. Grams and grams cancel out. Now we need to go from moles of water to moles of hydrogen. And as we said earlier, for every 1 mole of water, we have 2 moles of hydrogen. Moles and moles cancels out. And we now want to go to grams of hydrogen, so we use the molecular weight of hydrogen. For every 1 mole of hydrogen, it's 1.008 grams of hydrogen. grams of hydrogen, sorry, I had this flipped upside down. We want to do the reciprocal, so we can have grams on top, 1.008 grams of hydrogen for 1 mole of hydrogen. Moles and moles cancels out, and we end up calculating 0.423 grams of hydrogen. Well, we know we started off with a 5.50 gram sample of benzene. In order to determine if we have any oxygen present, we need to see, we add up both of our masses. If they do not equal 5.50 grams, the remaining mass is going to be my oxygen. But if we add up 5.073 grams plus 0.423 grams, we end up with a mass of 5.499 grams of sample, which is roughly 5.5 grams of the sample that we started off with. So we don't have oxygen in this case. So we can move on to the second step of determining the empirical formula. In order to determine the empirical formula, we need to convert our masses to grams, our masses to moles, and whichever the smallest number of moles we have, we divide both of our values by the smallest number of moles to get a ratio. So let's go ahead and convert these masses to moles. And so in order to go from grams to moles, we multiply by the reciprocal of the atomic mass. So in the case of carbon, it's 1 mole of carbon per 12.01 grams of carbon. Grams and grams cancels, and we end up with a mass of 0.4224 moles. Sorry, moles, not masses, of carbon. In the case of hydrogen, we do the same thing. We multiply by the reciprocal of the atomic mass of hydrogen. Grams and grams cancel. We end up with 0.423 grams moles of hydrogen. So in this case, 0.423 is roughly the same thing as 0.422. If we divide them both by 0.4224, you roughly get a ratio of 1, or you get a value of 1 for each case. So this tells us we have carbon is in a 1-to-1 ratio to that of hydrogen. So my empirical formula is CH. But they asked me to find the empirical formula and the molecular formula. In order to determine the molecular formula, they need to have provided us with the approximate molar mass, and they do. So in order to find the molecular formula, we know the empirical formula is the most simplistic formula that you can have and just shows relative ratios. In order to find the molecular formula, we have to find the ratio in which they differ from. So we find the molecular weight of my empirical formula. We add up the weights of 12.01 plus 1.008 gives us roughly 13.02 for my empirical formula for benzene. I then take my molecular mass that they provide us, grams per mole, and I divided it by 13.02 grams per mole, and I'll get a whole number ratio of roughly 6. When I get that ratio, I multiply that value by each of my subscripts, which I get C6H6, which makes sense because if the greatest common factor in this case is 6, and if you divide them both by 6, you end up with the empirical formula. I know this problem had a number of multiple steps that we had to go through. It is important that you go back and practice this problem and attempt it first by yourself, and then rewatch the video with me going through each of the steps. Thank you.